few problems I want to take a video of to get you back on track if you're having trouble. Number 4, first of all, this is already in factored form. That's the huge part. Notice there isn't a blank for that because we're already there. So when you're in factored form, we can tell what the zeros are. The zeros are x-intercepts. So right out of here, I can see -1, I can see 4, but right here, there's a 0 of 0. Because if I put a 0 in, 0 squared makes 0. So how do we make 0 when we put in values for x? So 0 is going to have a multiplicity here of 2. That's the power on the zeros factor. So, and that means it's going to touch when we graph, and we'll talk about that in a second. And then -1 is going to have a multiplicity of 1, and it's going to cross. And the 0 of 4 also has a multiplicity of 1, it's going to cross. So we go by the odd powers up here, okay? And that's an even power, so that's why it touches. All right, so if I were to graph these right now, I have one right here at 0, and I know that that's going to touch. It's just going to touch there. I have one at -1, and we know that's going to cross, and we have one at 1, 2, 3, at 4, and we know that's going to cross as well. Well, what does that mean? Well, the polynomial function, hopefully you know, is something that, you know, kind of looks like this, right? Or they could both be going up, or it could be as simple as this. These are polynomial type functions. Domain's all real numbers here. So here's the deal. We need to know which one of these it looks like. Does it look like an odd power? Does it look like an even power? Well, if you thought about expanding this out right now, you would get, actually I can do that real quick. You don't have to do this. This is just for illustration purposes. You would get x squared minus 3x minus 4. And then if I brought this x squared through, do we see that the highest power would be degree 4? So basically, we want us to know that this is going to resemble one that's x to the 4th power. There's no coefficient out here, so I don't have to put -5x squared or anything, or 4. I just have to put x to the 4th. And what I know by that is that the ends are going to go up. That's the real important part. So basically, from these end caps, we know we're going to go up on both sides here. Well, what's the rest of it going to do? It's going to cross, it's going to come up and just touch that, and it's going to come down, go up and cross. So that's the shape we get, and the multiplicities are determining the behavior at the zeros there. And then the y-intercept, well, I hope we can see that that is right from our graph, just 0, 0. If you don't know how to do that, plug in a 0. You would get 0 squared times 1 times I think it was at -4. It's all going to be 0 because 0 is wiping it out. All right, so that's how we do if it's in factored form. Now, just a couple of points before I carry on here. You need to factor these as quickly as possible. You don't have to do synthetic division. So basically what I'm trying to say is if you look at number 5, if you look at number 6, there are ways of factoring these without synthetic division. So, you know, we talked about the grouping method for this one. All right, so if I take a GCF of x squared out, that leaves me with x plus 2 right there. And then on the second part of grouping, if we take the -9 out, that will also leave an x plus 2 on the inside. You just need to know how to finish this. So this would be f of x equals, and then that's going to be x squared minus 9 and x plus 2. But as you can see there, hopefully this is a difference of perfect squares now. So now complete factored form here would be x plus 3, x minus 3, and then the x plus 2. And then we could do our zeros, our multiplicities, y-intercepts, all of that off of here, and we could go sketch our graph. I'm going to leave that for you to check the solutions online to do that, but I just want to talk about how to get these in factored form. That's where most are struggling with. All right? So then number 6 here, people with synthetic division, don't worry about it. Just take out a GCF out of the entire problem. If I take this GCF out, look at this, x, and then I'll have an x squared plus an x minus 20. And then the problem just flows. Oh, I have an x out, and then I have x plus 5, x minus 4 from my guess and check. So that's my factored form, and I can go figure everything out. Okay, now I'm going to jump down. I'll hit 7 and 8 here in a second, but I want to jump down and just tell you about 10 and 11. Now 10 and 11, you're going to have some trouble with these. You're going to be like, oh, well, I don't know how to factor them. And grouping doesn't work. So what I suggest you do is synthetic division. Now, I'm not going to do these ones on the review for you because I did a really good video of this process, and that is also on the Google Classroom. So check that out for ones without synthetic division, or without being able to factor easily. But what you can do is look at my solutions online to see how I got to those answers. All right, I am going to do a couple more things though, if you're struggling with this at all. There's two ways to tell if a C value is a 0. One of the ways, which a lot of kids like, is literally just do f of C. If it comes out to 0, you got yourself a 0. I mean, think about it. If I put this in for x and I get a y value of 0, that would make it a 0. So if we do that for this one, it actually does not come out to 0, which means this is not a 0. But the other way to do it is to put your coefficients in here for synthetic division. I'm going to show you that way now. So basically, I took all my coefficients. I needed a filler right here, right in between. I needed a filler of 0. But if I just check the number of 2 with synthetic division, 1 times 2 is 2, add down 2, 2 times 2 is 4, add down 3, 3 times 2 is 6, add down 8, 8 times 2 is 16, add down 18. The remainder here is 18. Again, if we did f of 2, I'll save you the work. Maybe you already did that, but you will get 18 for that. If you don't get 0, what that means is this is not a 0. Okay, that's not a 0. As opposed to if I was going to check, whoops, need my filler in there. If I was going to check -1 to see if that's a 0, carry down the 1, 1 times -1 is -1, add down, I got myself -1, 1, 0, multiply back 0, add down 2, multiply back -2, add down 0. Woohoo! I did get a remainder of 0. So that means -1 is a 0. Okay? You can do the exact same thing on number 8. It's just that you would use a C value of 4 for this one and a C value of -3. But the question, the question is if the following's a factor. All right, last thing I'm going to do in this video right here is I want you to have a little practice again with the potentials. All right, this right here is x to the 5th. It's straight up and simple that the most zeros a polynomial function will have, the maximum number it could have, is the degree of the function. And think about that. X squared, the most times that can cross the x-axis, 2 times. X cubed, the most times that can cross the x-axis, 3 times. So, x to the 4th, the ones that look like this, the most 1, 2, 3, 4, they can hit as 4. So basically the power, the degree, is the maximum number of zeros. All right, well then remember this is the p right here, but it's not 12, it's the factors of 12. So 1, 2, 3, 4, 6, what am I missing here? 12. 1 times, yeah, we got them all there, okay? And then here the factors of 3 are 1 and 3. All right, so remember here the scenario is plus or minus, so positive or negative, P over Q. So every combination that we're doing, we're coming up with 2 potential zeros. Okay, so I'm going to highlight these in the color as I go. So I'm going to do 1 over 1, so plus or minus 1. That's 2 zeros there. That's a possible 1, possible -1 sitting there. Then I have to do the 1 over the 3, so I got plus or minus 1/3. Now what I don't do is go backwards through this. I always start here as my numerator. So 2 over 1 would be my next one. And then 2 over 3 would be the next one. 3 over 1 would be the next one. These are not in any specific order. It's just the order I like to follow. So 3 over 1. Then you'd have 3 over 3, which is 1. Then we would have 4. So plus or minus 4. Then we would have plus or minus 4 over 3. Then we'd have plus or minus 6 over 1. Then we'd have plus or minus 6 over 3, which we already have as 2. And then we'd have 12 over 1, so plus or minus 12. And then the last one would be 12 over 3, which is 4, and we're good there. Okay, again, I'm not saying that 10 and 11 are not important. They're very important, vital to your test. But I did do another video. Check it out on Google Classroom.